alaikum wa rahmatullahi wa barakatuh. Today we will discuss about copper alloy foundry practice. Now, copper alloy casting, it is the earliest metallic object made from molten metal by man. It is about as early as 3000 BC. Now, advantages. The copper has got a lot of say electrical conductivity, uh, thermal conductivity, corrosion resistance, appearance, non-toxicity, bearing qualities, but it has got certain limitations, and one of its most important is the cost factor. Now, molding of copper casting, now less affected by heat to moderate degree. Due to its pouring temperature or melting point is not as high as that of steel. However, intermediate pouring temperature and high specific gravity allow to have sand casting like green sand casting, dry sand casting, using natural sand or synthetic sand, but we generally use low squeezing pressure while molding. However, to have a better finish, we can go for plastic molding, precision casting, permanent mold, die casting with a few alloys. Centrifugal casting of big pipes can be done, that of copper. Now, molding sand depends upon the what types of alloy we are going, copper alloy we want to go for casting, its weight, section thickness, what is the thickness of the section, and required surface finish. Now, then, however, low permeability gives good and more good surface finish, the fluidity to acquire uniform density and a smooth mold cavity. It should have a good fluidity. High permeability for longer casting needed to avoid gas formation, which may cause blows, pinholes, etc. Now, getting ratio from sprue is to runner is to ingot. Generally, it is a pressurized one, it is a heavy, specificity is high. Therefore, we generally go for pressurized casting, 2 is to 8 is to 1, and also can 3 is to 9 is to 1, can be minimum gating ratio. The ratio between the runner and the gate is from 4 is to 1 to 6 is to 1. However, arising, you know that the solidification solidification uh, coefficient, shrinkage coefficient of copper is 0.5% to 9%. Therefore, rising is very important. Many alloys has long freezing range, that of copper. This causes the high shrinkage plus long freezing range causes dendritic mechanism. Now, when there is a dendritic mechanism of freezing, then that is difficult to feed, and the shrinkage get dispersed and very difficult to get sound casting. Therefore, the riser has to be of sufficient amount to be placed in a very efficient manner and can be multiple type, and this only can give a directional solidification. Temperature gradient is also a parameter to have a sound casting. Therefore, if we can reduce this temperature gradient, this can overcome the long freezing range. However, a hot riser can also give a good feeding mechanism. Shells used as far ends of the casting will provide sound uh, castings. Therefore, methods to obtain steep temperature gradient is by chill. When we provide chill, then the gradient between solidus and liquidus get reduced because it is having a fast cooling. Therefore, it can overcome the stiffness of the temperature gradient. Hot riser also gives a good support to steep temperature gradient to overcome this steep temperature gradient. Uh, Padding at the gate of the risers so that the liquid may remain in a good sufficient superheat. We can provide insulating padded gates, and therefore the casting can overcome this uh, steep gradient. Now, as the melting temperature is not is moderate, therefore is about 1080 degrees centigrade, then therefore we can go for a good alternative very similar to that aluminum. However, it is 60% requires more heat than that of aluminum. Keeping that thing in view, melting furnaces can be crucible furnace, reverberatory furnace, electric arc furnace, induction furnace, etc. But melting procedure, first of all, the charge should be a clean foundry scrap with a peak of desired analysis or ingot of desired analysis mixed together, and they are being charged. Metal is melted down under oxidizing temperature atmosphere. It is about 0.05 free gas, because there are so many materials which may get reduced, and therefore oxidizing atmosphere gives good support to the surface of the molten metal. Now, after melting down, addition of alloying element like zinc, tin, lead, or special hardeners just to improve hardness, because it is a ductile material. Therefore, we need to, so that we can have a sufficient hardness, we use certain hardeners. After adding there's hardeners, we need to improve the temperature of the melt, and therefore it is again heated so that it can the temperature can enhance 10 to 50 degrees centigrade above the pouring temperature. Now, drossing also occurs. Most of the element contains oxidizable elements like zinc, tin, aluminum, magnesium. They get oxidized, and therefore we we have to control this oxidation and and have the control the drossing. Now, this drossing, they form dross from maybe have all these oxides of zinc, aluminum, and all that. Specificity is low, and therefore it will reduce the specificity of the alloy. However, because they are having low specific gravity, therefore dross will float above the melt. And however, this formation of dross will cause loss in energy. Fluxes or charcoal is employed to minimize this dross. Bottle glass thinned with borax keep the surface clean. Minimum agitation decreases gloss. More agitation will give more chance to oxidize, and therefore minimizing this agitation will of course reduce dross. Now, oxygen in copper melt. Copper readily oxidizes in molten condition. Now, but the solubility of oxygen increases the temperature about 0.0034% in solid state to 0.04 to 0.05 at by weight in pure molten copper. If element used in alloys, zinc, tin, aluminum, they get oxidized themselves, and therefore the oxygen in copper can be reduced. Now, hydrogen in copper. Now you can see this graph shows that this is the melting temperature. Now at melting temperature, the hydrogen pickup is very high. You can see a lot have the pickup is high. Now solubility of hydrogen in copper increases with the temperature. It is very much change at melting point. Now, at melting point, its solubility is about 5%. It is about 5%. Now, hydrogen pick up by molten metal from the furnace atmosphere, because there can be a moisture content in the combustion air, and that can be picked up by the copper melt. Also, in the ladle of the molding sand or the cold sand, the moisture content can can react with the molten metal and give hydrogen, which can be picked up by the metal itself. Now this picked up gases, hydrogen will cause gas holes, microporosity, dispersed shrinkage, prevent cavity from being filled. They will stop, retard the movement of the fluid. However, the top riser may also swell due to all these things. Now, reaction of oxygen, hydrogen, and impurities. Now, oxygen and hydrogen may form water vapor at high temperature. Oxidizing atmosphere preferred for copper-based alloys. Reducing atmosphere promotes porosity. Now, hydrogen can be reduced by purging or flushing it with the nitrogen gas. When we purge, blow hydrogen gas, then this hydrogen gas pick up oxygen. This nitrogen gas carry, push, segregate. The hydrogen gas gets segregated along the nitrogen gas, and they being taken by the nitrogen. Zinc flaring. Now zinc react with oxygen, which gives white flame or flare, and they come up on the surface of the molten metal. Now, carbon also form gases, which also bubbles out. Now the solubility of carbon is low, and therefore can be used as a deoxidizer to remove the oxygen in it. Now sulfur forms gas, can also be used, but solubility of sulfur is 0.05 to 0.08, reducing carbon content below a particular percentage. Now therefore oxidization of the metallic oxide causes embrittlement. But all these in oxidizing material elements being used, they causes embrittlement. Therefore, that should be properly tackled with. The element which combines more effectively with oxygen than copper can be used to remove oxygen from the copper-based alloys. Now, for example, phosphorus, lithium, boron, calcium, magnesium, aluminum, silicon, beryllium, etc. These are the elements which can be used as a deoxidizing agent from the copper alloy. Now, however, about 0.02% of phosphorus is needed for this oxidization. After this oxidization, pouring should proceed at once, otherwise the copper alloy may get reacted with the atmosphere and get oxidized. And this is all about. Thank you.